Hi friends, today in this video I'll talk about actually what are the different parts in an extrusion die. So that I gave the heading as what is the geometry of an extrusion die. So myself Dr. Basant Kumar Behera from Crescent University, Chennai. So before going for actually what are the different parts in the die, let us see this diagram. So in this diagram, what is happening? Uh, it is showing actually how actually a die is connected with the extruder. So the left hand side of the diagram, the left part of the diagram is showing the extruder part, and the right side of the diagram is showing the uh, die part. Again, the die part is with actually certain sections. That one only we'll talk today. So first the extruder. So inside the extruder actually we are having, we know that actually there will be a barrel, and inside the barrel we will have the screw, and the material will come through that one, and finally actually it will enter the breaker plate, and once the melt will come out of the breaker plate, then it will enter the die. So the left hand side of the breaker plate is the extruder, and the right hand side of the diagram, that is right hand side of the diagram in the screen, that is actually on the right hand side of the breaker plate, we will have the uh, die. So in the diagram it has been shown as A, B, C, D, E. A is the extruder, and B is your die, C is the breaker plate. That breaker plate only dividing your extruder part and the die part. Then when you will go for the die, inside the die, that means the total section of the die, that is again consists with actually two sections. One is called approach section, the other one is called land section. So repeating again, the die consists with actually two sections. One is uh, approach section, and the other side is actually land section. So the function of a die is to change the cross section of the flow channel, that is the circular channel inside the extruder, because the barrel geometry is a circular one. So that's why the circular channel in the extruder to the required shape of the product, whether we are requiring a pipe or you are requiring actually other type of shape. So based on actually your requirement of the shape of the plastic product, what will happen? The cross section will change, and it is achieved by a streamlined die channel which is formed to obtain a gradual change of the cross section. And the die channel is made up of two sections. The die part of the diagram, one is uh, the approach section, and the other one is the land section. So now what is the approach section? What is the function of the approach section? The approach section of a die, it is of a convergent channel. So convergent meaning is actually the cross-sectional area reduces, where the cross-sectional area decreases from one end to the other end. Generally, the one end of the approach section that will be connected with your extruder. That's why the diameter of the approach section for one end will be same with the diameter of the uh, extruder. Whatever the barrel diameter of the extruder, that will be also the diameter of the approach section. But the other end diameter will be low, it will be decrease. That's why it is a convergent channel where the cross-sectional area is decreases. And during when the melt will flow in that convergent channel, it will compress the melt. So the compressed melt is achieved when the melt flows through this section. This section means that approach section, and due to the compression of the molecules when it flow through the approach section, it creates an uniform pressure, and it also eliminate the stagnation of melt inside the die. So when you are going to design the die, and particularly for the approach section, the important thing you have to see actually, that is the what should be the angle you have to put actually, because at one end the diameter is more, the other end actually diameter is less. So it is a convergent channel. So what should be the degree? That means at what degree it will converge from one end to the other end. So generally, as a thumb rule, it has been taken as the angle should be lie between in between 20 degree to 30 degrees. But this is a thumb rule. It is not actually fixed for always, because it depends upon also the viscosity of the melt. The melt which is flowing inside your extruder, that will decide actually what should be the angle for the convergence, for the approach section, which is actually usually a convergent channel. So 20 degrees to 30 degrees, but it is not actually it is not necessary to take actually within this range always, because suppose the melt is actually high viscous, then on that case you have to adjust your this angle, then it's convergent angle. So for highly viscous melt, the angle may be reduced. It's not necessary to take 20 degrees. You can take in between actually even from 5 degree to 20 degrees. Similarly, if you are producing actually small part, one thing is actually viscosity more, then on that case don't go for actually this 20-30 degree range. Maybe you can go for less than 20 degrees. Similarly, you can go for less than 20 degrees of the uh, convergent angle if you are going to produce actually small, geometrically actually small parts. For bigger part, you can put actually the angle between actually around 30 degree also not a issue. But if you are producing actually smaller part, then better go for actually uh, lesser angle. That's why while designing the parts, judiciously you have to select the taper channel angle. Uh, so because your decision of this angle, it will have an impact on the output rate as well as actually uh, the product shape, as well as actually the defects, because sometimes actually the defects will be there. So if you are not adjusting the angle actually properly, then on that case chance of actually defect also will be there. So that's why very judiciously it has to be adjusted. So based on your knowledge on material, what is actually, what is the viscosity and what type of part you are going to produce, based on that one actually you have to take a decision. And the next one is actually land section. The next part, because as I'm repeating for the die, there are two sections. One is actually approach section, the other one is land section. So the approach section area actually continuously reduced, but in land section, for the land and constant. So the cross section of the land section, generally it is constant, and it is desired cross section of the product, because that means what should be the diameter of the, what should be the cross section of the land section, that one will be decided by the product, what type of product you are going to produce. So what will be the geometry of your product, same will be the geometry of the land section. Now you have to decide actually, because in case of uh, approach section, what was happening actually, the diameter was reducing continuously. That's why you have to take the what should be the angle, taper angle in design. But in case of land section, that is not the matter. That means the angle is not an issue, because here actually diameter is always a constant, area is constant. But here you have to decide actually what should be the length, what should be the length of the land section, because based on the length of the land section, your output other thing will actually depend upon. That's why like actually was judiciously choosing actually the angle for the approach section. Similarly, actually judiciously you have to choose also the length of the land section. So the length of the land section should be long enough to produce a sufficient back pressure, so that the extruder will exit smoothly, because sufficient pressure will not be there, then the melt, that means the product may not come out actually from your die smoothly. So on that case, the part will be rejected. And the land lengths and the land section should help to bring a perfect appearance of your product and correct dimensions of the product. The length of the land section, how much you have to take, it also depends upon the output from the extruder. Generally, output of from extruder is measured uh, in terms of kg per hour. That means in 1 hour, how much kg of product you are going to get. That is the output measurement in case of extruders. As well as actually it depends upon the type of material, what type of material you are using. Material means actually whether when you are making it melt, whether actually viscosity, like actually in PVC and all, viscosity will be more. But in case of actually suppose you are dealing with actually, for example, low density polyethylene, then on that case actually viscosity will be less. So based on the type of material and how much output required, you have to choose the length of the land section. So as a thumb rule, what people used to do, uh, they used to take actually the length of a land section in between. Actually, this is thumb rule, because at the beginning actually for a designer he don't know how much to take, so they used to try in between this range based on actually some input given by experience of some other designer earlier. So generally the length of the land section is taken in between 15 times to 50 times. 15 to 50 is a range. Sometime you can choose actually 20 times or 25 times, or maybe minimum length also you can take when you are going to design actually this rod type of product. So 15 to 50 times whatever the thickness of the wall, thickness of the product, wall thickness of the product multiplied by 15 to 50 times, that may be taken as the length of the land section. So these are the crucial points to take care while designing the land section and approach section in case of die, simple die. Then other things actually, because so many other parts will be there in between actually your approach section and land section, that is based on actually the type of product you are going to manufacture. But these are some basic things which will be there actually in all type of extruder. So for today this much, and I will continue my other videos on this die design in future. Thank you all.